Hey everyone, can you hear us? Back row? Awesome, thank you. There's like 500 of you there and we totally weren't expecting that. So when they built this thing, they said there's gonna be about 10 people, maybe people will sign up. And as we were walking in, we're panicking. So bear with us, all right? I'll let you introduce yourself, Gillian.
Hi, I'm Gillian McCann. I'm a cloud architect with Liberty Information Technology, which is based in Belfast, Northern Ireland. Liberty IT delivers high quality engineering for the Liberty Mutual Insurance Group.
Hi, I'm Jill Armstrong, and I'm the technical lead on our cognitive technologies team, and I work out of the Belfast office with Gillian McCann.
So we refer to them sometimes as the Jillians, or if you want to refer to them individually, that one's Jill and that one's Gillian. My name is Niranjan Hira. I am a solutions architect and I work with the Amazon Lex team. My job really is to work with customers as they're hoping to adopt Lex and some of our other language technologies. So what we're going to talk about today is building highly personalized customer service experiences at scale. So if there's one thing that you walk away with today, it won't be, here's how you use Lex. It'll really be, here's how you convince your business to use Lex. It'll be, here's how you deliver a real chatbot from an operational perspective, right? Because when we talk about chatbots, often they get relegated to that notion of, well, it's just a science project. You're just saying that you'll do this. It won't really work, right? And A, it's terrible that in this day and age we look at a science project and say that's a bad thing. But B, more importantly, look, these are the things that will change the way that customers interact with us. So let's talk about how those interactions will be different, and let's talk about how chatbots create business value, right? So some building blocks first. Now, I'm not going to tell you about everything you need, because, well, that would take too long. But show of hands, who's worked with Lex before? All right, that's the expert contingent. You guys need to catch up. What about Poli? Awesome. So Poli is our text-to-lifelike speech service. And you give a piece of text to Poli in one of several different languages. And using one of 52 different voices, you can have Poli enunciate things with impact, with respect to grammar, with respect to punctuation, right? So if you haven't heard that whole bit before about punctuation saves lives, it's the fundamental difference between having text that sounds monotonous and robotic versus text that sounds like somebody's actually reading it out. From a speech production perspective, one of the important aspects with Poli is its ability to get text right the first time around, right? With many of these services, you can use some kind of markup language like speech synthesis markup language or SSML. Poli's no different. But the question is, how often do you have to go to that? Because that tells you how much post-production work you need to do, right? Well, what's Amazon Lex? You can ask these guys. They know what Amazon Lex is. But Amazon Lex is a service that allows you to build conversational experiences. Okay, mouthful, but let's talk about what that means. What that means is I've got a chatbot that I can say things to in a language that I understand, and it's not something that I've been trained to use, right? So let's go back to basics. When you use a kiosk, when you use an ATM, when you use somebody else's service today, one of the things that you have to do is to get through that little cognitive leap of, I need to think like you. I need to think like you, insurance provider. I need to think like you, bank. I need to think like you, airline, right? The hope with chatbots is that you get to use your language. You get to use your words. Now, that is a hard thing to actually create. And we'll talk today about how we go about doing that. But the benefit of doing that is I can have somebody literally speak in their language to the chatbot. And when I say their language, I mean their choice of words. It's not necessarily a gate change. It's that something changed for my flight, right? It's not necessarily an upgrade. I might think about it as I've been bumped up, right? And those are the kinds of language that you'd like to be able to support. So how does this work? Generally speaking, when you speak with Lex, the way that Lex as a service works is it talks about this notion of bots having a collection of purposes, right? Every bot has a purpose. And that purpose is what you refer to as an intent behind the scenes. And that intent is then ultimately fulfilled by code that in many cases you, the developer, write, right? So we have this notion of a bot being a collection of intents. Each intent then is expressed as a set of sample utterances, right? If I want a coffee, for example, I might start off by saying, give me a coffee versus I'd like a versus I want to buy one, right? Those sample utterances then also have additional information. If I'm booking a flight, for example, right, I might say something like, I'm going to New York, or I'd like to go to New York, right? And then the name of that city, New York, that's in there is a slot. And if you think about that flight example, which is usually an accessible example for people, you think about the fact that you need at least an origin, a destination, dates, and maybe you'd like to specify an airline, right? Because I get miles on this airline, and so I want to make sure I fly that way, right? But that's a good example of something that is optional, right? I need to know where you're starting from. Your phone might tell me that. I need to know where you're going, but I should be able to decipher whether or not you prefer a particular airline as part of that conversation. So that to me is the difference between a required slot and an optional slot. What Lex will do is it'll manage the dialogue so that when you say that this is a required slot, it will prompt the user if those slots have not been provided. If you do provide those slots as part of your normal sentences, then Lex will fill those slots and continue to the next one in the list, right? So what kind of bots have people built already? There are a good set of case studies on the Lex product page, and they're growing. It would be good to take a look there, but I'll just share a couple of examples with you. We've seen people build employee support bots. These are where people often start. I don't trust you, I don't trust this crazy new service, but if you want to do this quote-unquote science project, try it out for something we do, such as a password reset, such as tell me where so-and-so is, or for example, just to look up people's phone numbers from the phone book, right? The other one that I've seen people do, every developer wants to build some kind of a bot that either spins up or spins down a collection of instances. That is a fun bot to build. If you haven't built one of those, I'd highly, highly urge you to try that, right? It is cool to see a whole CloudFormation stack start up because you said go, right? And when you do that a few times, you get a little bored with it, but at least you can prove it out. The other bot that's fun to build is the customer service bot, the contact center bot. If you think about the conversations that people dread when they're calling into the IVR, right? Those conversations are often conversations that are non-value add from a human perspective. I just need to know whether or not you have your frequent flyer number. I need to know whether you have your hotel reservation number, right? If I could collect that information from you, then I can get a human being on the phone with you to actually help you solve your problem. Ideally, I'd be able to do more using the automation, but at a minimum, I should be able to do those things, right? So think about where in this chain of events a bot fits, whether it's pre-qualification, whether it's actually doing the work, or whether it's just at the end where all the bot is asking for is, hey, how did we do today, right? It may or may not make sense for a human being to always ask that question. The other example we've seen is business intelligence, right? Where a bot, for example, in a boardroom where you're having a meeting, we've all done this where we're having this conversation about, I don't know, same store sales, and somebody asked this question that just wasn't covered in the slides. The normal response to that is, let me get on Skype, let me get on Chime and ask the person who produced this data, hey, could you also tell me what this is? You know, what was the same store sale for this particular category, right? Imagine if you could just ask that question of a bot that was in the room with you. Now, that presents unique challenges because you're not going to have that bot read out the numbers to you, right? You need to think about how to present that data, whether it be a screen, whether it be producing a PDF, however that might work. But there are often examples of some kind of interaction to say, now that you've given me the top 3, could you also give me the top 5 or the top 10, right? So, it's not all fun and games. There's fine print. There's always fine print, right? Bots rely on APIs. And APIs, A, aren't always present, and B, don't always work. And sometimes they're really, really slow, right? If I'm texting something and it doesn't respond back in 30 seconds, I don't panic, right? The big red button doesn't come out. But if I'm talking to somebody on the phone and I don't get a response in those 3 to 5 seconds, I panic. 00099, agent, and there goes your containment rate. The other thing that bots don't get is the fact that they need to adapt on their own, right? They can improve in the sense that they can collect more data. They improve in the sense that deep learning helps, but they don't, for example, collect subtlety and sort of improve in their ability to handle sarcasm. That just doesn't work, right? So I don't want to leave you with the impression that the bot understands these things. Let's accept those limitations, right? We still like bots. Why do we like bots? We like bots because they don't sleep, right? I just got off a flight at 2 a.m. and I can ask a bot to do something for me. I pick up the phone and ask a person to do that thing for me, and the person would say, well, call between the hours of 8 a.m. to 8 a.m. Eastern time, Pacific time, whatever particular time zone that team works in, right? A bot doesn't judge me because I like my things a certain way. And if I can express those feelings to a bot without being judged, it's okay. But I'll often talk to a person and know that somewhere behind the scenes there's a subreddit page where somebody's making fun of me, right? And that's not necessarily what I want out of life. So bots are helpful there too. The other thing that I think is really strange about bots is you can train people. Some of the best customer service agents are those who try to get to know the customer, right? But at the end of the day, this person is just populating a database, right? And it's a job, right? It's not getting to know you because I'm going to see you for coffee later. It's really unlikely to happen. And if anybody's done that, raise your hand, because that's an exception I'd like to record. But if you're expecting a bot to do that, that's just something a bot likes to do. It likes to know that you prefer a non-smoking room, or you prefer a particular size car, or you prefer a certain seating preference, right? It's designed to know these things, and doesn't consider them to be work. So with all that said, we're all super excited and we want a bot, right? So let's go build one right now. When you say that internally, right, regardless of which organization you work in, I've worked with by now hundreds of them, the answer is pretty much the same. Well, hold on a second. Have you thought about, so here's a collection, right? So have you thought about what happens if the bot screws up? Have you thought about the scale of the fulfillment? You know, have you thought about what will happen if customers leave? What if customers are upset? What if we make the TechCrunch news cycle, right? Well, yeah, all of those things could happen, right? That's why start small. Think about what you're building. Let's collect that list. This is really good data, right? When people say this is a terrible idea, it'll never work, this is going to be a PR nightmare, that is awesome data, because that's your to-do list. Those are the risks you need to mitigate for as you continue down this path. One of my personal favorites on this is, how will we know if you're successful, right? And that's a really hard thing, because from a developer's perspective, it compiles, it runs, the test case works, we're good, right? But for some silly reason, people wanted to actually do things beyond that. And I don't think people appreciate the fact that my interest was to learn something fun and cool. And now that I've learned something fun and cool, I'm kind of over it. But they want us to continue, right? So the better approach there is to just bake that into the first cycle, right? And so what does that mean? And how does that work? Alien dude who's hiding down there will help us out throughout this conversation. So we start with why, right? Take a step back and say, if I'm going to pretend to have a business reason for building a chatbot, let's just at least come up with a good business reason to do that, right? And here's your toolkit. You start because you want a better customer experience, right? People are complaining because you're only available certain hours of the day. You want to do it because you want to talk to customers where they are, right? You want to do it because you want to save the company time and money, These are all good templates to start with. You want to do it because, hey, if we could just do this on the chatbot, I wonder if we could additionally offer people this other thing that we do. We could upgrade them, right? We could call them and do that. We could text them and say, you already booked this thing with us. Would you like us to, for X dollars more, do this other thing, right? So these are all good templates to start with. But you have to measure them. Alien Dude, like I said, help us out. So how do you measure some of the things they're doing? So let's take some examples. As a restaurant, right? Peak time, one of the top calls that the restaurant gets is, hey, how long is the wait for a table for two, right? And while the host is trying to answer that question, the people who are physically in the restaurant are being asked to wait. So one answer is, well, you should get 2 people. Another answer is, well, maybe we could automate some of that, right? And then the question is, well, how do you measure whether it's working? You measure whether it's working by looking at how many interactions worked from the automated side and did not ultimately yield phone calls that extended to the actual host. How much additional time did the host have, right? You think about FAQs. We get asked this question so many times. We put this FAQ up on the page. It's on SharePoint, for God's sakes. Everybody knows it's there, whatever your version of SharePoint is. It's just that nobody seems to be able to find it. Well, great. Just create a chatbot that sends people the link, right? Problem solved. How will you know that's working? Well, see how often it gets used. See how often it results in a follow-up, right? Self-service. The number one question is, what's the status of my claim? I filed this claim 2 weeks ago. Nobody's called me. I did mention Liberty Mutual were here, so you see the claims analogy. But you measure automated interactions, the number of times that those calls did not carry on to a human being, and how fast claims were actually processed because these people, instead of answering the phone saying, yep, we have it, an adjuster will call you to schedule blah, right? Instead of that, the person gets the information that the customer needs and can continue. Because in many cases, what these calls are really doing is managing anxiety, right? As a customer, when I pick up the phone and say, hey, nobody seems to have called me, it's been 2 weeks, what I'm really saying is, I'm anxious. You haven't seemed to have done what you said you would do, right? So if you could just tell me you're doing that and perhaps over-communicate, problem solved, right? Another one is office productivity. And we'll hear a little bit more about that later on. But imagine things like, where does so-and-so work, right? And what's for lunch? If you're working in a large enough organization where you have multiple office spaces, those are good things to get information about. But of course, people are going to ask you for all sorts of fun things. Give us an example.
Yeah, so in one of our earliest prototypes, even though it was designed for office productivity, as Hira said, so many people asked it to tell them a joke that I eventually got quite frustrated and put in a response that told them to get back to work, which I found funny, even if they didn't.
So yeah, tell them a joke. But it's not just that, right? It's what about stock quotes? What about the time? What about this other thing that doesn't make sense for this particular bot? And that's where it's really important to quote Alien Dude, right? If you've got a good definition of why you're doing this, then you can harken back to that and say, guys, we said this wasn't a general purpose super smart thing. It's not an office intelligence yet. It's a chatbot that serves this purpose. And once you can stay the focus, right? So once you can stay that course, you can stay focused on it, what winds up happening is that you can actually deliver something. Otherwise, you're going to wind up doing 15 different joke and weather and time intents without ultimately solving the problem you set out to solve. Well, how do you do that, right? So 2 approaches that we've seen, and I think it's good to have both of them in parallel, really. If you have the data, if you have transcripts of what people are talking about, start there. It's great. It's really helpful to do that. But the other thing you absolutely have to do is get to the point where you have 2 people talking. When you listen to 2 people actually pretending to be in the situation that you're trying to address, you'll get some really good feedback. So as an example, if I was to create a bot that would help somebody unlock their password, right? I would start out by doing the I'm locked out, unlock, password reset, etc. Right? Somebody comes in, and the very first interaction I hear is, I can't access. Right? Okay, that's a good point. I haven't thought about that. But what I just said is not as important, because in my head as a developer, I'm thinking, okay, I've established the problem. You need to get unlocked. I just need your ID, and we're done. But if you think about the actual interaction, you'll realize that there's a lot more to it. So what I suggest is to do a script like this, right? Just get up on the whiteboard and write down what people are saying. And remember, there's not just two parties to this. There's actually at least three parties to this. There's the user, there's the bot, and there's the system. And that system is what needs to keep track of the conversation to say, in this example, right, we talk about visits, appointments. Well, scheduling those appointments is a pain. Getting availability for those appointments is a pain. Well, there has to be an API that actually does that. Now, when you're having that conversation, I can almost guarantee you that you'll get into, well, but we don't have this particular feature. Let that conversation go. We're not talking about that right now. Just like when you're designing the web form, you don't always get all the way into the nitty-gritty of how that model is supposed to be supported. There are times when you'll talk about the API behind the scenes that you really just need to move on. Record it and move on. The other piece of advice there is start with the friendly use cases and don't get bogged down in the alternatives. Because the alternatives are many, but they're not as valuable, right? The 80-20 rule really applies here. When you've done this a few times over, so once you've done a few scripts like this, say 4 or 5 of them, then you can rationalize them down to some kind of a conversation flow. Do not do the conversation flow to start with, because you'll find that that biases you toward the conversation flow that's in your head. What makes more sense is to hear people naturally talking to each other, pretending to be in the situation, and then taking that data and reducing that back to some kind of a flow. And coming back to this point, right? It's not just the bot and the user, it's also the app. So the important thing there is to record what the app will do in response. So the screen changes to show the top 5 same store category sales, for example, right? Now, does the screen have an option to drill down from there? I don't know, it's your app, right? But you do need to think about it. Oh, yeah. You need to make sure the API is ultimately there. And here's the thing that doesn't go away. If you've got an application that has peaks and valleys in terms of its usage, and the API correspondingly is used there, expect that you'll have those peaks and valleys in terms of the chatbot as well. There is a quote-unquote peak time, peak week, peak hour for your chatbot as well. The question is what it takes for you to find it, right? So these are really important questions. How will it work? How will we know it's broken? One of the important questions that you do need to be able to answer before you actually put it in production is, who's going to try to address it if something breaks? And how will we know if something's broken, right? So one of the suggestions there is test it out. We have another story for you.
So here it has here, run a game day. So this happened to us. We decided to run an exploratory testing session with, I think, 20, 30 users. And we hadn't had that many people using the chatbot at once. And we immediately started getting, I don't understand, latency issues. And what it actually was, we were notified in real time that we hadn't provisioned the DynamoDB correctly. Our read-write capacity was too low. And also we hadn't turned on auto-scaling correctly. So it's very important, the operational side and the monitoring side, to have that real-time notification of issues across all the services that you're using.
Thanks. So we talk about, I'm going to do a shameless plug, I am a solutions architect after all. We talk about these well-architected reviews, right? Well-architected review is essentially a questionnaire that allows you to think through that little checklist of what goes right, what goes wrong, when you make an application ready for production scale, right? One of the things that's really important here is a chatbot is not just this little Lex bot that you've created. That's the easy part, right? A chatbot in production at scale is several additional components around it. We're going to rely on the Jillians to tell us more about that. But one of the things I do want you to walk away with is, yes, Amazon Lex makes it really easy to build a chatbot. You can walk away from this session right now, go to one of the walkthroughs, and something like 20 minutes later, you will have a chatbot, right? But taking that chatbot to production and making it successful requires additional effort, right? And in order for you to be able to demonstrate that that was in fact successful, you need to have thought through the why you did it and the how you're going to collect that value and then show back to the business what you've been able to create, right? So let's talk about some of those other bits.
Hi, yeah, so Jillian and I are here today to really talk about our experiences building a digital assistant chatbot with Amazon Lex in the enterprise. Liberty Mutual is a Fortune 100 company with over 50,000 employees in 800 offices around the world. We've rolled out our chatbot to a pilot group of employees of 3,000 in multiple offices and countries with a rapid rollout planned. When we say chatbots for the enterprise, what we really mean is chatbots at scale. So behind me here, you can actually see a video of our chatbot. In recent years, Liberty Mutual has really invested in trying to improve the employee experience, of which the chatbot is the latest evolution. The aim is really to make our employees more productive in their daily work, but also give them that engaging, consumer-like experience within the enterprise. So the use cases that we have initially focused on have been around central employee functions, like HR, IT help desks, automation of simple tasks, common searches. And as you can see in the video, we're showing things like we can do people searches, lookups, we can do password resets, we can answer questions on common HR policies and practices. Another point there in the video, as you can see, we're trying to get a more personalized, contextualized experience for each and every employee. So you can see that when I ask the question of what's for lunch, it replies with the answer for the Belfast office. But if I'm traveling to Boston, I can also ask the same question and get the answer for that location. And you may be sitting there thinking that's a really trivial thing to put into an office productivity chatbot. That was one of our top searches on our company intranet. Another important point is really around the conversational design itself. And what we've done is try to add a mechanism for feedback for employees to suggest ideas and provide feedback into the bot itself through the conversation. So that's a little bit about the what and the why. This slide is the how. This slide represents the high-level components that make up our chatbot serverless architecture. And hopefully the first thing you notice is it takes more than Amazon Lex to build an enterprise digital assistant. So let's take a quick walk through that. So our employee asks a question, what's for lunch? So that's an utterance. And what we do is we send that utterance through our chat API, which is an API gateway which we authenticate with IAM. We then use Lambdas and DynamoDB to really create a conversation session and conversation history. As part of that, when we start a conversation, we load context. Context is key in every conversation. And we've been exploring how different contexts can really provide that personalized experience for each and every employee. So the context that we're exploring are user context of my office, my job role, my manager, my device. How does that impact the answer? We've also been exploring how what we call conversational context could also personalize the answer. What questions have you already asked? What answers have we already provided? Does that change what we're going to say in the next intent? And then also, previous conversations. How could that impact the answer? So those are all areas that we're exploring at the moment. So the employee has said something, the utterance, we have context, we've got session. This is where we now use Amazon Lex. We use the natural language understanding of Amazon Lex to recognize the intent of what the employee is saying. We have experimented, as you see in the video, it was text-based, but we have been experimenting with Poli and voice and really trying to understand the differences of where it makes sense in the workplace to have a voice bot versus a text-based bot. So utterance, intent recognition, and then we move to fulfillment. And this is where, as here it says, you actually need APIs. You need to write code. It's not magic. If you don't have the back end or the API that provides the answer, the chatbot's not going to be able to give you anything more than, I don't understand. So we have different types of fulfillment. We have fulfillment where via VPC-based lambdas and our direct connection on our VPC, we're able to talk to our on-prem APIs. We have lambdas that integrate with other AWS services. We have lambdas that actually have just hard-coded responses. And then if you were actually building the weather bot, we have lambdas that call out to external third-party APIs. So we've got utterances, we've got intent recognition, and we've got fulfillment. We've got a chatbot. Have we finished? No. What we've built into our chatbot is a mechanism we call chat stream analytics. So it's the constant analytics and insight into what our employees are saying and how we can improve the chatbot by looking at what our employees are saying and suggesting. And we're doing that by streaming the Lex responses into Elasticsearch and creating a series of conversational boards that we have looked at. So now, is that the architecture over? So hopefully when you look at this, you see more than a chatbot. You see a complex distributed system. You see a serverless architecture. So to go to the point of operationalizing that in production, monitoring that, what do we do? So I know we're here to talk about Amazon Lex, one of the cool AI services, but there's other services you really need to be friends with. Amazon CloudWatch and Amazon X-Ray. So we use CloudWatch. We have many lambdas. Lambdas have CloudWatch logs, but what we're doing is we're using log group subscription filters to stream those into a centralized place, which is Elasticsearch. So we can have a good view of what's happening in the application. We're using CloudWatch metrics for two reasons. We're using the out-of-the-box metrics on key services to create alarms. Those alarms then give us that real-time notification that I talked about, so we can see things when there's latency on the API gateway. We can see when the lambdas are throttling, so that we're able to act and react in real time. We also use the custom metrics, where we can create more business usage values that we can look at in our CloudWatch dashboards. So as I say, CloudWatch is your friend. X-Ray, simply turn it on, look at the data, and really start analyzing. We did see issues with cold starts on our VPC lambdas that we were able to rectify by looking at the data that we've seen in X-Ray. So I talked about our analytics dashboards. This is an example. And it's important that, so we can see things like the number of users, types of conversations, but really what we're looking for here is, how is Lex performing for us? What are we getting right? What intents are matching the correct answers? And also, what are people suggesting that we don't have in the bot? Like, for example, we didn't have booked travel. It wasn't something that we had APIs for, that we weren't going to add, but people did ask it. So we were able to see that we were getting a lot of conversations in a particular area that we then could enhance. So we use these boards to really understand what our employees are asking and also how the bot's performing. So we've built this feedback loop in from the very start. But a feedback loop is only useful if you can action it very quickly. And to do that, we've coined a term in Liberty Mutual called conversation as code.
Thank you. So as Gillian's just said, we want to be really responsive to our users. We want to respond to their feedback right away. But we're a large enterprise organization, so we have very high engineering standards. So we need a process that allows for both, which is what conversation as code is all about. So what is it? Well, the first and probably unsurprising thing is that everything in our architecture, including our chatbot, has to be created through code. CloudFormation, custom resources. For the chatbot itself, we use the Amazon Lex model building service called through a custom resource as part of our deploy. Now, why do we do that? We need everything to be traceable, testable, repeatable, and observable. And so doing everything programmatically allows us to have that. Now, you're probably thinking, that sounds like a lot of work. It sounds much easier to just do everything through the console. And there definitely is some initial setup, but once you have that in place, you get visibility across your team of everything that's changed at any point with your chatbot and your fulfillments, and you can easily roll back to an earlier state. And you can also have a full continuous integration and continuous delivery pipeline like we have. As soon as code is checked in, tests are automatically run, it's automatically deployed to our development environment, and we're kept informed of everything that's happening to our Slack channel. Now, the great thing about this is it's completely repeatable. So we can take our stacks and our bot and replicate them, or we can even put them in a completely different AWS account and be certain that they are exactly the same. So this allows us to use one account for our own testing and a completely separate AWS account for the production chatbot that our users are conversing with. We already have over 500 versions of our bot and growing every day. It would be terrible to have to keep track of all the changes manually through the console, let alone be able to confidently replicate that in another account. As Gillian's already mentioned, we have live analytics, and you've just seen that, and also alarms that let us know if anything's gone down or it's just simply running too slow. And all of that adds up to us being able to make a change anywhere in our system and roll it out to our users in minutes with complete confidence. So one of the reasons we can be so confident is our strong testing strategy. The earlier you can catch an issue in your development lifecycle, the easier and quicker it is to fix. So of course, we unit test. All of our fulfillment lambdas are written in Node, not just because it gives a nice consistency with the web development that we also do, but also because I just love JavaScript. Jillian's not so sure. Some of you are not so sure. It's awesome. We use the Mocha test framework and Lambda local test library so we can test our lambdas right in our IDE. Of course, we code review everything to make sure people are writing tests that are as high quality as their code. We also use static analysis. It is such a simple thing to put in place, but it will save you a lot of time and maybe tears. Anyone who's written CloudFormation knows that a single misplaced space can cause a lot of trouble. If you have a validator, you can catch that as you write it. We also have a set of custom unit tests that we use to validate the files that we call the Amazon Lex model building service with. We found it was easy for developers to make simple mistakes like putting a duplicate utterance in, and this catches them right away, long before we use them to call the service. So earlier I said that as soon as code is checked in, it's automatically deployed to our development environment. And that is true as long as all the tests pass. If the tests don't pass, end of the line, doesn't go forward. But our team's awesome, so all their tests always pass. It's always automatically deployed. And at that point, we run just a quick smoke test, make sure everything's up and running, hooked up correctly. And we also, in our development environment, run a component test. Now, this is done using Newman and run directly against the bot runtime APIs to do a regression test on intent recognition. One thing we found very quickly was that it's very easy to change the behavior of an existing intent when you add a new one. Some of you know what I'm talking about. Now, we have over 50 intents in this bot at the moment. We're adding new ones all the time. Going back and manually checking all of those would be very time-consuming. But we want to be confident that all the existing behavior and recognition we had before is still in place when we add new functionality. But, as we've already said, once we've deployed it out there, we don't just hope for the best. Observability is really important, and Gillian called out some of the things we have in place for that, which you'll see up on the screen. We want to give our customers a really optimal experience when using our chatbot. And that means being able to respond really quickly when things go wrong. But you can't do that if you don't know that something has gone wrong. So those alarms are critical. And there's no point knowing something's gone wrong if you haven't put things in place that let you track down the root cause and fix it really quickly, like centralized logging. Frustrated users will very quickly not be your users at all. But all those tests, they just test the technical side. A poor conversational user experience can frustrate users just as much. But to test user experience, you're going to need some humans. And when you test with humans, that's where you see some real challenges. So firstly, people's expectations are very high, thanks in part to things like Alexa. Thank you here.
We'll take it.
So people will ask it unexpected things, like we've mentioned, for jokes, or the time, or who they are. I don't know why people don't know that. But they'll also ask it expected things in unexpected ways. So we find that even how people say hello or thank you can differ from office to office, let alone country to country. We definitely have one or two phrases in Belfast that our US colleagues don't use. And writing a good conversation is really hard. You can't just take your website text or your FAQ and stick it straight into a chatbot. You're really going to have to think about that conversation. So here's talked about interaction design, and that can be just as hard, if not harder, probably harder, than your technical design. And don't forget your error handling, your APIs go down. All of that needs to be conversational as well. Look, building a simple chatbot is simple. The Amazon Lex team have made it super easy to hop into the console and build a quick prototype. But building a good chatbot, one that can run at scale with useful functionality and a great user experience, is really, really hard. But it's worth it. We are moving to a place where we are humanizing technology. Instead of you having to do all the work to understand technology, it's starting to understand you, and that's awesome. I'm really excited about the potential here. I hope you guys are too. But in the spirit of a good conversational interface, I think we'll stop here and take some questions.
Questions? If you don't mind, just come up there and ask the question so we can actually hear you. I don't think we've got mics.
For the uneducated side, you said that when you added an intent, it changed the behavior of another intent.
Sure. So what you can find is, so when you add intent, you add a set of utterances that describe the types of things that people would say that would match that intent. And when you add another intent, what you can find is that maybe some of the things that are in that are too close. So now things you thought would match a different intent now match the new intent. It can actually be quite unexpected because the more intent you have, the more complex it gets to sort of manage them all across.
Yeah, it's the key point of ambiguity, right? Every time you add utterances, if you've got language that is reasonably close in other intents, Lex may have to work harder to find the intent that you originally started talking about.
Yeah,
and that's where the testing is important.
Yeah, that's what I was about to say.
Thanks.
That's why the testing is so important. So the component tests that we run against Lex itself on every build, we immediately see where things that had matched before no longer match. And we can immediately start going in and examining what the issue is. So they are a vital piece of our deployment.
They're vital as our chatbot gets bigger, and it used to just be us two and Kellen, who's not here. But now we have a bigger team, so people aren't as familiar maybe with all the other intents. So this just lets us quickly check that. But yeah, it's easy to knock off other parts of your functionality.
Other questions?
Two questions. How long did it take you to start the project from the time you released the first production chatbot? And second, how big is your team?
Sorry, would you please, for the purposes of the conversation, repeat the question?
Yes, so the question is, when did we start the project, how long it took to get it into production. Is that right?
And size of team.
And the size of team. Okay, so the story is I was the team. It started January, and then Gillian joined, so there's the two of us. And
On the science project.
The science project piece.
The Gillian
The
team.
MVP, the POC, prove out Lex. 6 weeks to get somewhat that architecture in place. Took a lot longer to get it into production. So we did that with the two of us, and we proved out that it is worthwhile. And what we then did was, the biggest issue we had that time was there was no build SDK. So on the 9th, I know the date because I was waiting. The 19th of April this year, the build SDK was released when Lex went GA.
Yep.
So at that point in time, we then had to come up with, well, how do I take this out of the console? Because in the enterprise, we have POCs in the console, anything else, everything through code, everything through a build pipeline. It's how do I take slots, utterances, intents, everything I created that was amazing, how do I get it to production? So that's where we come up with the Lambda-backed custom resources, JSON files that represented the bots, metadata. So we come up with a pipeline for our bot itself. So May was when we first hit production with a team of 3. We rolled it out to 80 people. And that was really more just, wasn't real usage. We spent then, I think, another 3 months with a couple more people, and the focus was functionality. What is enough to release it to 3,000 employees? How much HR, help desk, multiple office staff? So it was really, that time was about the functionality. So we've released it to 3,000.
Yeah, so we have a team of 6 at the moment.
So I'm just trying to think timelines now. 6 weeks finished POC. May, so we went to production. We were waiting on Lex to go GA.
Yeah. And then our next drop will be all 50,000 employees.
So the other thing I do want to point out, and I want to say thank you, because when you launch a new service like Lex, you really are grateful for customers like them who help you improve the service, right? It's one thing for customers to complain, hey, this doesn't work, it sucks, whatever we've all done that, right? But it's really helpful to have customers who will tell you, well, here's the thing that you're missing, and here's the bit I'm trying to do. And be patient enough to work with you as you kind of iterate through that. Because at the end of the day, the pain that they take on then allows the rest of you to be able to see an improved service, right? And so that model has ultimately been extremely effective. So thank you for that.
I think also from an internal perspective, that model has worked too, in that we have, I would like to say we've broke the back of how to build Amazon Lex chatbots at scale within Liberty Mutual. So the work that we've done in the employee space with the build pipelines, the test frameworks, is we have many, many AWS accounts. We can take what we have and we can replicate it across all our business accounts for consumer bots, for automated agents. So the same process by which we've helped evolve Lex, we've also helped evolve Liberty Mutual's ability to build chatbots.
Hey, you can come next and stand. It's cool.
I was just curious, you're trying to build this thing that acts like a human. Do you find it better to inform the user that they're interacting with a bot, or do you try to actually fool them into thinking that they're actually...
I'm going to let you answer that question, because that's a good one. But please repeat it first.
Yeah. So the question is, you're building a bot that's trying to act like a human. Is it better to tell the user that it's a bot, or should you try to pretend you're a human? Is that right? Yeah. So opinions do differ out there. My opinion would be that you should definitely inform the user that it's a bot. And you should always give the user a way to opt out if they don't want to talk to the bot. And your measure of success is that they don't opt out. They choose to talk to your bot. It's providing useful functionality. It's giving them something they want. And they don't feel the need to say no. Now, there is people who will not want to talk to a bot. Now, ours is very clearly a bot. I don't think we have enough people on our team to write responses to everybody. So people are aware that it's a chatbot. But yeah, as we move out to more customer-facing chatbots, there could be scenarios in which it wouldn't be clear to someone. I think you should always be honest and say it's a bot. Because people will be a little more forgiving if it doesn't understand. It's not just, as you say, a very stupid human who can't understand them.
Okay, so if my understanding was correct, we use not permission to deploy nodes. And I'm curious because I look it up and people say that it doesn't support it, and the permission doesn't support it out of the box. So I'm curious about why.
Yeah, so when we say CloudFormation, so the architecture has a lot of components. You know, DynamoDB, API Gateway, which is supported. But
So
what
do
we
you
use...
want to repeat the question
Oh,
first of all?
sorry. I'll repeat the question. You're asking about how to build the bot with CloudFormation when it's not supported.
How do you use CloudFormation to deploy the bot because it looks like Next is not supported
Yeah.
out of the box.
Yes.
Yes, okay. So how do we use CloudFormation to deploy the bot? So what we do is we use Lambda-backed custom resources. I don't know if you're familiar with custom resources. Yeah. So literally, we build lots of the components of DynamoDB, the API Gateway, and when we're building the bot itself, we're using the custom resource, which is essentially CloudFormation, provisions what it can, and then it jumps out to the Lambda, and we use the API, and we build it that way. And we build it with a combination of JSON files for the bot, the intent, the slots, and we use the model that they have. We've also put metadata around it ourselves, so there's some information and classification, like HR, IT help desk, that we've put on the intent itself. So that's how we do it.
Yeah.
Yeah.
Question?
Talking to Siri is like talking to an idiot because there's no ability to keep context. Can you talk a little bit about the depth of context that you have in your solution and the type of things that you can realize in terms of context?
So as I say, we're experimenting and we're trying to evolve because context is key to the conversation. But what we have at the moment is something I would say is very simple. It's based on the user, like the office, you know, your role. So we don't have some magic AI happening that is looking at other, like a load of different data sources. It's literally very simple things that if you're based in Belfast, you get this answer. You know, so it's a start of context. As I said, we want to explore, and we've been in lots of sessions on that sort of subject. It's like, what context is going to be important? And it's also how to think about our bot itself. You know, it's doing at the moment relatively straightforward things. You know, how much context do you really need? But we are exploring that.
But there's a fine line. So people do ask us things like, well, if I ask it this today and I ask it this tomorrow, will it remember? But then equally, almost the same people will say, well, I don't want the bot to know it was me asked it because that's really creepy. So there is a fine line between being able to take the context and understand what the user asked before and use that, but not make it feel like it's creepy and it's like spying on everything you do. So we are doing some exploration around that. What can we use? What will users feel comfortable with?
Another question?
Well, I was going to ask the same question. Thank you. But to expand on it, when you have this conversation, maybe you can beyond the context, there's the term criteria and dialogue, right? All what we're seeing with Dex 200 in fact is, you know, figuring out the slots to get to the intent over one prompt. You can ask prompt for more, but it's always to fill the slots for that intent. I want to go to the next turn in the dialogue. Where do we actually manage the fact that, you know, I asked you a question and now I'm going to ask you a follow-up question about something related that you already know, but I'm not going to provide that information. So what's the weather tomorrow for that? And then the next question is, how do I get there?
Yeah. So the crux of it, if I understand it correctly, is in the area of almost what we refer to sometimes as short-term context, right? I just asked you the question about what's the weather in Orlando, and then if I say, how do I get there, it would be helpful if the bot knew that the there in question is Orlando. There are things that you could automate today that do that, right? But the service today does not provide that. What we've seen is that, in fact, one of the workshops we did today, one of the things we showed people how to do is to say, when you're referring to the country in question, when you say, I'm traveling to this country, we recognize that country for the rest of the conversation, and when there's a reference, right, we return to that country. But that requires code today. One of the things that we're looking at is whether it makes sense across the board, and we need more feedback really, whether it makes sense across the board to be able to fulfill these kinds of, as another example, I asked you for a report for the top 3, as I said before. And if I could then follow up there by saying, what about the top 5? So I'm not really saying the rest of it again. I'm not really saying, I asked you for the top 3 same-store sales by region, right? I'm just saying, how about top 5? And it's up to the bot to recognize that that's in context of that previous statement. Don't have a good answer for you today, to be honest, right? There's that, it has been done, it can be done with code, but from a service perspective, that is harder to do because it's not very clear whether it generally applies.
Yeah, just to answer that. So that's when we talk about our context, it's our code. Like we've loaded like session really, and we've loaded attributes that are important, like the office, and that is carried out throughout the conversation into our fulfillment lambdas, so that at any point in time, those fulfillment lambdas can pick out attributes that would personalize the answer. So it is all through code at the moment that we're doing that.
How does it integrate with Slack or Twilio? Does it integrate, can you have Slack or Twilio go to the next and use that?
Sure. So the question is, how does it integrate with, for example, Slack and Twilio, right? Out of the box, what Lex does is it allows you to, it takes on this conversational piece, but it also takes on some of these integration points, right? Because when you work with any one of these services, you generally have to maintain some infrastructure to be able to respond to outbound event hooks from that service, right? And so Lex takes care of that for you. What you do is you can, whether it's Twilio or whether it's Slack, Facebook, Kick Messenger now, what you can do is you can create what we refer to as a channel. And behind the scenes, that provisions a REST-based endpoint for that service to invoke. Those are what you might refer to as quote-unquote out-of-the-box integrations, right? Then what developers might also want to do is to do integrations to other services like Jabber that, for example, we don't have. And that same pattern works even there. So you have a Lex bot, it out of the box will connect to Facebook and Twilio and Slack and Kick, Amazon Connect, those kinds of things. Well, what you can then do is using that runtime API and using that architecture pattern, you can also integrate with other services. Does that answer your question? Okay. Any other questions?
So, a lot of times when people text, they use shortened phrases and things. How good is Lex at understanding that?
So the question is, when people use text, SMS, for example, as well as messengers, they're often using acronyms, short forms that aren't necessarily the full version of the word. How good is Lex at figuring that part out? And I'll tell you, out of the box, there are very limited things that it'll understand. It might understand a yeah or a no in different versions of it. But out of the box, there's little that it'll do with acronyms, for example. One of the things that you can do with sample utterances, you can provide some of that data and some of that feedback. You can get some of the way there. But I will tell you, I have a 12-year-old who will write in ways that no Lexbot will understand. So.
Yeah, we definitely found very quickly that if it wasn't understanding, it wasn't down to the Lex service, it was we were bad teachers, we hadn't taught it well enough.
Yeah. You had a question.
According to the messaging, like is there a way like when the chatbot is sending back the message, can we depend to that as like if we have 5 people or 5 messages, they're looking at it and suddenly see that okay, chat is that's not the answer which is supposed to go through. Can we reply again to that?
So the question is, can we tap into the messaging? So for example, the default response from Lex is not, for the purposes of this conversation, for whatever reason, acceptable. I'd like to be able to add to that. So it gets a little complicated. There are ways to do it. It depends on the particular channel. If you're doing web, of course. If you're doing a custom integration, Absolutely. If you're doing the likes of Facebook, it requires a little more code, right? And one of the other things to question is whether you're adding to or replacing what Lex says. Adding to is significantly easier than replacing what Lex says. It takes a little bit of code to replace what Lex says. Now, if you know that up front, in terms of when the Lambda is producing the response, API says this, that's a whole lot easier. But what you're describing is more human needs to intervene because the human has better understanding of what's going on.